Okay. Hey, everybody. Oh, gods. There we go. Okay. It's Friday. How's everyone doing today? I'm Brian, and I am working on some Rust today. Thanks to everyone who came on last Tuesday. Thanks to everybody for the positive comments and thoughts about what we talked about over there. I'm not going to go over it again so much. If you want to catch it, the VOD is up on YouTube, and you can go and check that out. I also did a few things with that last video that I'm actually kind of proud of. One of the things I've always wanted to do was to make it possible to put transcriptions on there, and for the longest time, didn't have that capability. I don't have time to, we were going to do it for every podcast, and I was like, I don't have time to do that. The AI at the time for like otter.ai was not 100%. I had multiple speakers, so there was another issue there. And so I started playing around with riverside.fm. So we're going to do some Rust in a second. Riverside.fm, they're not a sponsor. Did not a bad job. I had an hour and a half stream, hour and 43 minutes, I think, the last stream, and we're able to, it knocked it out in about, I don't know, I managed to get through about 10, 15, 20 minutes, probably 20 minutes of editing where things came up where I was like, I would mention somebody's handle on here and it didn't translate properly. So my I just I thought it was kind of cool. It's a free service that I so far. They're probably using the transcription as a way of training its AI. Okay, I mean, fine. That's fine. If I influence an AI, I guess I'm doing okay. But yeah, so go to it's riverside.fm. If you can download podcasts. If you want to get an audio transcription, you can do that. There's a couple of stop starts that I did today. The other thing was Google has in YouTube has the ability to set stream content, and you're going to see some things minus my stream key here, obviously. There's a bit of a delay, so apologies on that. To do closed captioning, which I've selected here, takes about another 10 seconds on the buffer, so you might see some issues there. Normal latency is about 10 seconds. As you can see, I'm a little late and a little late. So there's closed captioning, and there's also you can also upload and edit captions as you're going. So I have in my video here. This is the Riverside.fm stuff. I actually tried this in Microsoft Word and it didn't work so well. But you can click off the closed captioning. You can go over here and see the different subtitles that are available, either auto-generated by YouTube, which is good, could be better, or you can just use auto-translate. So I thought that was interesting. I wanted to make sure that I see a lot of professional podcasts, a lot of professional streams have transcriptions, including timestamps of things. I think the next thing I want to try out is chapters, so I can set it up and go, okay, at this point I stopped talking about mental health and went on to talk about security, because I could have put those in there as well, like around 30 minutes. I think when I reviewed the video, I made the switch from talking about the mental health issues I've been having to security stuff. So I could have put a little thing in and said, hey, if you don't want to go there, you can click here. And I could break it down by news article or what have you. So, all right, well, enough of that. Thank you to whoever's here with me. I appreciate you taking the time. I swear that will get less as things happen. So, what? This live event is over. Uh-oh. That's not good. Wait, let me restore chat. There we go. Okay. I popped out the YouTube chat as well. I don't know why it's getting ugly with me, but okay, let me copy paste riverside.fm in there again. If you're looking for the VODs, I have been making sure they stay unpublished, at least until I had a chance to take a look and make sure everything was okay with them. If you are looking for those, I can I'll make sure I publish them a lot sooner. And yeah, so I'm gonna go ahead and get started now. So let me make sure. So I got VS Code up. I have my browser up. There you go. There's my browser and my VS Code. Shut that off. I need that one still. All right, so how's everybody doing this week? I actually had a talk with my manager, which I don't normally do. Something I have never done in my 20-plus year career in infosec. I have not given my managers in the past, the kind of trust that I'm giving this guy. And it's either going to blow up in my face or it's going to be probably one of the best relationships I've ever had with a manager ever. So we'll see what happens. I'll let you know in a few months, if something changes. So, all right. We are going through, this is the site. There's that. Okay, we're like I believe we're on like chapter 3, chapter 4, somewhere around that area. So we're going to go back. So the blog post is talking about writing an OS in Rust. And this is a series of blog posts about Rust programming language. The GitHub code is here, so you can go to the GitHub repo and grab all the code that we'll eventually make. I want to say eventually. It could be that it's almost 80 degrees in my house, so I'm all like nice and comfortable and warm, and I want to go to sleepy time. So it could be that too. I also did some chest and back exercises today at the gym, which kicks my entire ass, the whole thing. There we go. All right. All right. Yep. That's not it. Oh, I see. I see what happened. Okay, duplicate. All right, now back this up, because what I want is a copy of the GitHub repo. At the same time, I'm going through these areas. All right, so one of the things that we tried the last time we went with Rust, which feels like forever ago, was I wanted to show that my VM actually worked. So I'm going to go over here to this and the terminal to pull up the terminal. I'm trying to remember keyboard commands. Is Control Shift backtick, and there you go. You see that. Let me pull up my. There we go. History. All right. I'm going to grab my history. Let's see. Rust. It was okay. So, one of the things that I needed to do, copy, and CD Rust OS, and so cargo build. All right, so Rust is good. We built it last time. There were a couple of error or warning messages about snake case because I didn't follow Rust conventions. So what you do is you go cargo run, and what happened was there's a command in there where I've already built, as you can see, I've already built the system, and there was a bin file that needed to be run. So I ran that, and it runs this command: system x8664 drive raw format. The target is this .bin, and when you do so, it pulls up. Oh, there it is, right there, and you see the hello world, which is the VM that we built So we have a basic kernel that booted up in a VM, which is being run by QEMU, and it's running in Rust. So the idea now is, according to the browser, so I just hit Control C to close the QEMU window. And so the next thing I will do is we'll start going through VGA text mode. Some of that I've already done, but I just wanted to show that I actually did get my environment set up with QEMU and everything's working for that. All right, so let me go Rust module. So now that we know that the VGA buffer works, which is what we tested by running, good Lord, which is what we tested by running and getting the hello world, shows the VGA buffer's working. We're able to insert ourselves into the VGA buffer to a certain memory point, which I believe is mentioned in probably VGA buffer, which I should go look at. VGA buffer is located right, where is it? Oh my hell. Oh, there it is. Okay, so 0xb8000, that's the memory location for the buffer, right? And the unsafe function is we're injecting ourselves into a buffer without proving we are who we say we are. And that's why Rust doesn't like it. We're doing unsafe operations inside of memory. So, oh, also let me get some music on, courtesy of Chill Hop Music. You can go and check them out at Chill Hop Music. Yeah, there we go, chillhop.com. You can go check out some of their stuff. They have their fall 2023 out. I like to listen to this a lot at work when I'm at work. So, all right. And all right. So my viewer or lurkers, if you have any questions, please let me know. I may not know the answer, but we'll find them out together. That's the important part. That's the fun of doing this. I'm wondering, I don't know if the transcriptions will actually get the nuance. Like, is this fun? Question mark? So we'll see what happens. Close that. All right. We are representing our colors using different enumerations. I'm going to close this terminal window. Close that. Close that. All right. So we have all of our colors in here. Public enum colors. So black, the values 0 through 15. So there's 16. There's hexadecimal, right? So 16 values, black through white, blue, green, cyan, red, magenta, brown, light gray, dark gray, light blue, light green, light cyan, light red, pink, yellow, and white. Those are the 16 colors. I believe that's EGA resolution. I think or VGA in this case, but EGA, was EGA 8 colors? EGA monitor output. I want to say EGA was like eight colors. No, 16 colors. Okay, yeah. So EGA PC graphics adapter. Yeah, back in the day, I would have killed for an EGA adapter for my system. I actually had a monochrome monitor with a what is it? A CGA software adapter. So it figured out how to simulate different colors by using different patterns of from the VGA buffer. It's kind of interesting. That's how old I am. So yeah, close this. All right, we use a C-like enum. So for those of us who've forgotten what enums are, they are an implicit discriminator. So enums, in this case, allows the creation of a type which may be one of a few different variants. Any variant which is valid as a struct is also valid as an enum. So there you go. There's that. So you have, web events. You have I'm a kitty. Well, you can get up here too and learn Rust. Everybody can learn Rust. You probably type better than I do. All right. So here to specify the number for each color because of the REPR U8 attribute, which we have right there. Each enum value is stored as a U8, or an unsigned 8-bit integer, right? Actually, 4 bits would be sufficient, but we don't have a U4. So the shortest amount is 8 bits of memory that it can, or 8 bits stored for the variant. Normally, the compiler would issue a warning for each unused variant. By using the allow dead code, we disable these warnings for the color enum. Yeah, so the fact that we don't have as many values as we need to fill up that area, we can add additional, by adding the dead code feature, we suppress some warnings in this case when we go to compile. I'd imagine it would give you more issues if you didn't have that in, and then you would just have to explain or what have you. Maybe dead code's not something you want to use if you want to be verbose about your errors. I mean, it wouldn't be hard for a U8 for somebody to add a bunch of other values inside this code that could be used elsewhere. Maybe they created a new color like Gorch, and it's like, okay, well, Gorch is its 16th color, right? Technically, there's a Gorch color. I just don't know what it would show up on the screen as. So you might want to have those warnings for documentation purposes or what have you. So. All right. So to represent full colored code that specifies foreground and background, we create a new type on top of U8. So we have, all right, let's see. So there's that. So if you weren't here on the last episode, I moved to a new computer and borked a bunch of things, including my Rust environment and all that. So I did do a copy paste from the GitHub repo. And that is why everything seems to have been done ahead of time. It's not a cooking show. I normally kind of type this stuff in myself to kind of learn as I go along. So I did have to do a filter. Hey, Beta Wolf, what? How you doing? Glad you're here. Didn't know if you were lurking or if you were the single viewer or what was going on. So glad you're here to join. So all right, we have our derive, bug, clone, copy, partial EQ. I solved some crazy GCP Python stuff last night. Really? Okay. I did see your post. You said you were becoming more a developer than a security person or something like that. I was like, I don't know if that's a good thing. It sounds like you're doing well. So, I mean, I applaud you for learning all of the things that you can learn as a developer. You might find yourself needing to, move industry or, I guess it's always good to know some coding and some programming if you're a security person. All right, so we have our bug, clone, copy, partial EQ. That's right there. So we have a combination of foreground and background colors. So they mentioned that right here. Zero documentation on the entire thing, so I had to figure it all out by myself. So that means you need to write the documentation to help other folks figure it out once you've gone in, right? You're gonna take the time to write the documentation. Or maybe you can have ChatGPT do it for you. I don't know. Probably not. So we have REPR transparent. So there's REPR transparent. Right? Which one am I? Am I Padme or are you Anakin? I forget. I'm probably Padme. Yeah, I'm Padme in this case. I don't. This is a VS Code thing, so I don't know why it's putting these in. It's kind of confusing, but I'm gonna just kind of suck it up and just let it go. It doesn't add to the line count, so it must not exist inside the system. you see the struct color code 8 here, and then IMPL implement color code. So we're going to implement a color functionality. So we're going to create basically like a new method or something like that. So in this case, we call color code, and we're going to create a new color code given the foreground and background colors. So func new foreground color to background color to color code. So it's going to take a foreground color and a background color, and it's going to go foink, and then it's going to create a third color. Sometimes you'll get black on pink, green on white. You'll create different codes, I think, or different colors based on what you put in the fore and the background there. So I'm writing up Medium articles. I don't know. I played with Medium a little bit on my RSS feed. There's a lot of I have no doubt that your stuff will be very good and very useful, but the majority of stuff I found for cybersecurity on Medium is cold garbage. Okay, you said junk. I was going to say it's not even hot garbage. It's just sometimes it's just plain old ass incorrect, or they've plagiarized it from somebody else and didn't give credit. So yeah, so I actually had to take it out of my RSS feed because I was reading some of that stuff, and I'm like, yeah, that doesn't make any sense. So I'm not sure what they were trying to accomplish with that, but there it is. So, all right, we have our color code, which is going to be defined as color code background as an unsigned 8-bit integer. So colored code contains a full color byte containing foreground and background color. Like before, we derive the copy and debug traits for it. To ensure the color code has the exact same data layout as the unsigned 8, we use the represent transparent attribute. Now we can add structures to represent color, screen character, and text buffer. Well, that was not what I wanted, but it's kind of cool. All right. I was actually trying to click over here so I can make this a little bigger for everybody to see. And I will move. There we go. All right, so we have NVGA buffers.rs. Okay, so we have derive, debug, clone, copy, partial EQ, repr R. So repr valid forms is repr C. Okay. Struct. So this is a struct in a C format, I believe. Right. So since the field ordering in default structs is undefined in Rust, we need a way to define it. And we're going to use the C method by which to define it. So the structs fields are laid out like in a C struct, and this guarantees the correct field ordering. Seems like that's a miss on Rust's part. You would want them to have some kind of structure in Rust, or maybe the fact that it allows you that kind of flexibility is good. I don't know. So for the buffer struct, we use the represent transparent, which is down here. And then we struct buffer, and again, to ensure that it has the same memory layout as a single field. So we have characters, buffer width, buffer height. So buffer width, buffer height. U size is normally 25 lines. The width is usually 80 characters. So it's like a typical console screen for VGA, 80 by 25. That's why when you, well, I was going to say when you do that, but I've actually seen really, really small boot screens. Like when you go to Grub bootloader, it'll be really, really small, and you have to go in and make a change to like grub.conf or something to make the screen bigger so you can actually see what the hell you're trying to select when you're booting up your machine. Especially if you're dual booting and it's not a default setup. So you get like this like 2-point font. You can't see anything. And so you either need to know that Ubuntu is the one at the very top because you're using Grub, which uses Ubuntu. And if you're dual booting Ubuntu and Windows, the Windows one is usually at the very bottom of those options. So that way you can scroll down until you can fix it and make changes. All right. So volatile screen character, buffer width 80, height 25. Back in the day when you used to open up a command.exe, it was an 80 by 25, box, 80 characters wide, 25 characters long, and yeah, that's what would come up. All right, writer. So pub struct writer. Okay, here you go. Writer type that allows writing ASCII bytes and strings. To an underlying buffer. Wraps lines at buffer width, which we know is 80, right? Oh, you can't. Okay, I was gonna say I didn't think you could see the light up. So yeah, you see where it says buffer width 80. There you go, and buffer height 25. So it wraps lines at 80. So it won't do like a new line. It'll just go okay, start and put it on the next line. It supports new line characters. And oh, it will support new line characters. Okay, my bad. So usize, color code is color code, and buffer is static mutable buffer. All right, so the static lifetime specifies that the reference is valid for the whole program runtime, which is true for the VGA text buffer. And now we use the writer to modify the buffer's characters. So first we create a method to write in a single ASCII byte, which is the implement writer bit here. So we're gonna a public function called write byte, which is self. Okay, so size of 8. So yeah, it's an unsigned 8-bit integer. And we've got buffer width and buffer height in here. It's trying to make sure that it doesn't, I guess, overwrite those buffers. So it doesn't try to write 81 characters. It doesn't try to write 26 characters long or whatever. It has to fit inside that screen or it's not going to show up on the screen. And then people will try to wonder what the hell's going on. I don't know what the to-do is. There's something else here that I think this person needs to add. I'm assuming later on in the chapter they fill that in. And as you can see in chapter 3, I don't see a to-do in here, so he must have gone back in and added those things. So, let's see, function, new line. Where's the func new line at? There it is. Okay, so yeah, at some point he goes in and he adds the new line stuff, and we'll discuss that later on. To print whole strings, we can convert them to bytes and print them one by one. When printing a byte, the writer checks if the current line is full. Okay, so it's checking to make sure you're not fitting 81 characters in here, or I've got 49 characters here. I need another 25 characters. Am I going to be able to fit those in? 49 and 25 is 74. So technically, yes, if I had 49 characters and I wanted to add 25, I could do so. But if it was 49 and I need to add 49 more, I'm going to have to figure out how to truncate that and add another 20 or so characters to the next line. It then writes a new screen char to the buffer at the current position. And finally, the current position or the column position is advanced. To print whole strings, we can convert them to bytes and print them one by one. All right, so we're gonna print our ASCII bytes and new lines. Hate how many of the medium cybersecurity people have their articles on the paid tier. The other thing is you're paying for it, and I don't know if the quality's there. So it's like, what am I getting by paying for medium? I don't know. I'd much rather pay for something that's, well, for me right now, things like Harvard Business Review, which has some great articles on leadership, which so far I haven't disagreed with a lot of things on there. There's really some excellent content on there. Or a dark reading, or some of the long form articles from Forbes or something like that. So I still, obviously we do news stories. So there's a number of blogs that I follow on my Feedly that are to infosec and security companies, but I haven't read much of them lately. Okay, so the VGA text buffer supports only the ASCII and additional bytes of code page 437. So we've already seen this. This is the code page 437. So these are all the characters supported by the VGA buffer. you could get a lot of mileage out of these out of this VGA code page 37 in text-based games from back in the day. Really quite impressive what they can do with that. Matter of fact, NetHack started nethack.org. Yeah, nethack.org, old text game that you could play online. Let me go NetHack images. So let me show you this. So there you go. You recognize anything? That's all code page 37 stuff right there. The dots, the lines, the boxes, the asterisk, the doors right here. We've got doors, the diamonds. I mean, you're just changing the colors, right? So this is a VGA text buffer. It's a little bigger. It's not exactly 80 by 25, but it uses the VGA text bits. So you got the ats, the ampersands denoting monsters. The line. These things are different items, that kind of thing. If you've ever played the game, but yeah. So there's different things that determine, and then it uses the VGA. It uses all the code page 37 or 437 stuff. So old game, yeah, like 1980 or 82. Sorry, makes me feel old now. I've tried playing that game. I just cannot win it. I can't. The best I can get to is like the dwarven town or the dwarven village, and it just kicks my ass every time. I can't win. So, and they've gotten better. They've got tiling and stuff too. They take and emulate the system, and makes it look a little prettier. But yeah. That's because people got tired of looking at what an ampersand was versus for that. So all right, so yeah, you see your lines. There's different lines, different areas. You've got your up and down vertical here. You've got so they made very judicious and very smart use of all of these characters that can be emulated in the VGA buffer, which is kind of cool. Oh wait, isn't there an RPG game that was made in that it's been in the works for like 20 years and just released? I don't know. I heard if you use Vim motions, you get a 10% learning boost in Rust. I don't know about that one. Beta Wolf. I do know how to use Vim though. I can get around. Oh yeah, I don't know about an RPG game that's been in the works for 20 years. The last one that was in the last couple that I remember that were in development hell was like Duke Nukem Forever, and there was one called Daikatana that was Katana. This was one that was in like first person hell forever. Jesus. Yeah, so announced in 97. No, it wasn't that one then. There was something that was like, yeah, it took forever to get this thing released. But Duke Nukem Forever was the one that and it also, like Chinese Democracy from Guns N' Roses took forever. Yeah, 14 years. Duke Nukem began under 3D Realms and went severely protracted development, lasted 14 years. Announced in 1997, following the success of Duke Nukem 3D, delayed several times, attributed to game engine changes, understaffing, and lack of development plan. So, yeah. Oh, there you go. Though this was exceeded in 2022, it holds the Guinness record Beyond Good and Evil 2. And maybe that was one you were talking about there. Vapor. Oh, that's cool. They call it Vaporware Action Video Game by Ubisoft. Oh, my God. That's harsh. Wow. Okay. So it's been referred to as Vaporware in 2022. It broke the record. Longest AAA development, more than 15 years. Oh, wow. When your creative director passes away, yeah, that's not good either. So, wow. Okay. 2016, 2020s. That's nuts. Did it ever come out? I guess it never did. It's still being worked on. Can you imagine? somebody at Ubisoft's like, oh, we're going to need to, reformat and, start from scratch. We don't want to put this on Unity. We're going to put it on Unreal or something like that. Anyway, I'm sorry, I digressed. Thank you, Beta Wolf, for the digression. I appreciate that. But yeah, it sounds like Beyond Good and Evil 2 was the game you might have been talking about. Okay, so try it out. Write some characters to screen. You create a temporary function. So we've already done some of this with the Hello World bit. Yeah, maybe. So the idea, I could add these things back, but this is one of the issues I've got with this tutorial. You're going to put these things in, you're going to run the QEMU, and it's going to give you Hello World, but instead of Hello World, like what it said earlier, it's going to give you this. It's going to give you this kind of output because it sees the umlauts, which are the 2 dots above the O, as their own value. And the O is going to, because it takes too much to put it into one area, so it's going to break it out into 2 separate sections. Where was I? Let's see. Oh yeah, Hello World. This creates a new writer that points to the VGA buffer at B8000, right? The new syntax for this might seem strange. First, we put the integer in B8000 as a mutable raw pointer, which is why we're doing it unsafely, because we are putting just raw pointers into memory without, any kind of controls. Then we convert it to a mutable reference by dereferencing it through the star. So here's the star up here. We dereference it. Dereferencing is unsafe as well. And immediately be borrowing it again through the mute function. So we put something into memory. We take away its the location key of where it's located somehow. That's the way I'm reading it here. We convert it to a mutable reference by dereferencing it. Okay, so and then immediately borrow it again through mute. This conversion requires an unsafe block since the compiler can't guarantee that the raw pointer is valid. Right, so you could, put it anywhere, right? And if it can't verify or guarantee that that's correct, there may not always be a value in B8000. What if you put it in B8001? Then the compiler is going to try to compile it. There won't be anything in B8000, and it will fail, or it just won't work, or it won't compile. There's a number of things that could happen there. Then it writes to the BH to it. The B is a byte literal, which represents an ASCII character. By writing the strings LO and world, we test our write string method and the handling of unprintable characters. So see the output, we need to call the print something function from our start function. So we're going to start print function something. When we run our program now, hello world should be printed in the lower left-hand corner of the yellow. Notice that the umlaut O is printed as 2 square characters. That's because umlaut O is represented by 2 bytes in UTF-8, which don't fall into the printable ASCII range. In fact, this is a fundamental property of UTF-8. The individual bytes of multi-byte values are never valid ASCII. So obviously some kind of control there. To never allow UTF-8 multi-byte values to be ASCII. Somebody figured out that may be a bad thing. I'm sure there's a good reason for it, though. So, volatile. All right, so we just saw that our message was printed correctly. However, it might not work with future Rust compilers that optimize more aggressively. Right. The idea is to write code that works everywhere or close to it. Problem is that we only write to the buffer and never read from it again. The compiler doesn't know that we really access the VGA buffer memory instead of normal RAM, and knows nothing about the side effect that some of the characters appear on the screen. So yeah, basically the compiler just does what it's going to continue on going about its business, and it doesn't realize that that is incorrect, that you're getting square URL'd there. So it might decide that these writes are unnecessary and can be omitted. To avoid this erroneous optimization, we need to specify these writes as volatile. That tells the compiler the write has side effects and should not be optimized away. So yeah, if you could do some kind of interesting. That sentence is not the point of Rust. It won't compile in potential future cases. Then I feel it's not written well. You're absolutely right, Beta Wolf. That if it might be that they explain themselves right. That if you don't set it as volatile, at some point in the near future, Rust might go, yeah, we're just not going to allow that. We're gonna optimize that away, and then your code won't work. So you have to put it as volatile with the idea that in the future, volatile will still say, okay, this is unsafe. This is this will have problems running it, and you shouldn't try to get rid of it just because it's there. There's actually a function or a need for it. In order to use volatile writes for the VGA buffer, we use the volatile library. This crate, this is how packages are called in the Rust world, or this is what packages are called in the Rust world, because they're cute about that stuff. Provides a volatile wrapper type with a read and a write method. So you can read volatile or write volatile. Yes, normally they use the read volatile and write volatile functions of the core library, and thus guarantee that the reads and writes are not optimized away. We can add a dependency on the volatile crate by adding it to the dependencies section of our cargo.toml file, which I believe our person has already done so. Volatile 026, as you can see right there. Okay. So yeah, we've done a lot of this already because, like I said before, I copied pasted from that instead of typing all these things in. Unfortunately, I had to put all of it in because I couldn't just go, oh, well, I'm just going to put this part, because as you saw, there were some to-dos up here on top, and then he removes the to-do and actually adds the new func line later on. So, all right. So, all right, we've added that there to make sure to specify version 026. Newer versions of the crate are not compatible with this post. So that's why we're using older versions like the 2018 edition of Rust. 2021 or 2023's version of Rust may not work with this code, which is another issue that we would have to discuss. But yeah, bootloader, volatile spin, several of these other packages are also kind of added or have been updated since. So, all right. Use volatile. That's in VGA buffers. Let's see. Where is it? Up top in it. Use volatile. There you go. Lowercase v for volatile, and then uppercase V for volatile. Okay. I don't know what the difference is, but there it is. For some reason, it uses lowercase v and uppercase V for volatile. So. Instead of a screen char, we're now using a volatile screen char. The volatile type is generic and can wrap almost any type. Let me make sure okay, it's still pretty low on the music volume. I just wanted to make sure I wasn't blasting people on the screen here. This is an Abercrombie and Fitch, folks. I'm trying to teach boring ass coding. I'm sorry, exciting coding. Exciting coding. We're learning OSs here. So, click on that. This ensures we can't accidentally write to it normally. Instead, we have to use the write method now. So yeah, we were specifying volatile write instead of, a volatile character instead of a regular write character. That way we don't run into issues. This means we now have to update our writer : write byte method. And we have implement writer public function write byte. So there's that. And we're going to, so this is B, new line. That's self.newline. Okay, so what does that tell us? Instead of a typical assignment using the equals, we're now using the write method. Okay, so that's right there. Write screen char. Now we can guarantee that the compiler will never optimize away this write. Interesting. Hold up, my wife is home. Yes. Okay, Jesus. Okay. Formatting macros. It would be nice to support Rust's formatting macros too. Okay. That way we can easily print different types like integers and floats. To support them, we need to implement the core format write, core FMT write trait. The only required method of this trait is write underscore stir, or probably string, right? Which looks quite familiar to write string, just with a format result return type. Okay, so there's not much difference between those two. So we need our, where's it at? Let's see, core, write. Okay, so there's the write string. Clear row, here it is. Write for writer. Okay, so we're on line 150, 46 to 51. Write stir, mutable self. Okay, S string, and then output that to format result. So it's going to send the output of write stir mute self string to format result to format it in a specific way that people can use. OK is just an OK result containing the type. So there's open and closed parentheses. Yeah. Now we can use Rust's built-in write bang and write line bang formatting macros. Okay. Now, okay, so in VGA, let's see, where's that at? Print something. Oh, okay. Scroll back up here. See, this is the other thing that confused me. He's all over the place sometimes. All right. Print. I don't have a print something. Oh, goody. Is he going to remove that before we get to the bottom of the page? I guess he is. I'm only about a third of the way down the page right now. So at some point he's going to remove the print something function. Okay, let me see if I can figure out where else this is. Right. Nope. Yeah, so at some point he's going to remove all of this port here. So interesting. Okay, you should see a hello. The numbers are 42 and 0.333333 at the bottom of the screen. The write call returns a result, which causes a warning if not used. So we call the unwrap function on it, which panics if an error occurs. This isn't a problem in our case since the writes to the VGA buffer never fail. That's true, because like we saw with the umlauted O, it's just going to show at a minimum 2 squares, 3 squares, how many ever bytes that it needs to represent the umlaut O in ASCII format. Because it'll never show UTF-8 characters in ASCII, so it has to just best guess, right? Okay. Right now, we just ignore new lines and characters that don't fit into the line anymore. Instead, we want to remove every character one line up, the top line gets deleted, and start at the beginning of the last line again. To do this, we add an implementation for the new line method of writer. Where's that at? There we go. Looks like this is it right here. Shift all lines up 1 and clears the last row. So we're going to make some changes to this so it doesn't look the same as in the code here. At some point down below, he's going to add some more stuff. Oh, no, he doesn't. He does that. He actually does pretty... Okay, yeah, so he does remove screen char. Interesting. Okay. Let character, yeah, self buffer. Okay. We iterate over the screen characters and move each character 1 row up. Note the upper bound of the range notation is exclusive. So the dots mean that the upper range is exclusive. We also omit the 0th row. The first range starts at 1 because it's the row that's shifted off screen. To finish the new line code, we add the clear row method. Okay, so that's the clear row methods down here. Right. I didn't do that. That's not me. That's so like I said, Phil is the one who did all the documentation of the code. I just pretty much copy pasted from his blog post. Let me see. Actually, yeah. Take those accolades back. I did not deserve. I did not deserve them. I'm trying to get to. Let's see, blog. Looking for the various chapters. Okay, so that's not them. All right, let me scroll back up here. And clear row method. Okay, we're with the clear row method. And post 03 branch. Okay, so it's copy link. Yeah, so blog post 03. Okay, there you go. Oh, that's how you get to the various branches. All right, so 4, 5, 6, 7, 8, 9, 10. Oh, we got a lot of stuff here, don't we? Oh, looks like he had multiple versions of these bits here, so that's good. Okay. So 3, post 03. And you can, go look at, what was it, source VGA buffers. Yeah, there you go. You can see all of his code and how it was edited and pretty colors and things like that. So, all right, get rid of that code page. VGA text. All right, and then I'll scroll back down about a third of the way. Buffers. I think we're right here. Okay, so it's a good thing I highlighted that. All right. This method clears a row by overriding all of its characters with a space generator. All right, so okay, so here's where it makes the changes. Self buffer characters, row column, right blank. So it's gonna do at least 25 character or one character, 80 lines long, all spaces. So it's gonna take the buffer width and add 80 characters of blank to bump it up one. This method clears a row by overriding all of its characters with space character to provide a global interface. So to provide a global writer that can be used as an interface from other modules without carrying a writer instance around, we'll try to create a static writer. All right, so static writer. Yeah, so he's going to change this up too. So by the end of the doc, implement format write for writer. So we're going to have right now he's got a public static writer that goes writer equals writer for column position 0, color codes. The new color is yellow on black, like a typical monochrome monitor was back in the day. Foreground being yellow text on a black background. You could flip it, but it just burned your eyeballs. Buffer unsafe. All right, so we have another unsafe, mutable, dereferencing, B8000, and then calling it again as a mutable buffer. So actually you work from inside out. So it's creating 8000 as a mutable buffer, it's then dereferencing it, and then that value is being mutable again as a point in the code. However, if we try to compile it now, we'll have errors. So nobody was trying to compile this. You're going to see unsafe. You're going to see dereference of raw pointer. Statics require immutable values. To understand what's happening here, we need to know that statics are initialized at compile time. So any static values are initialized at compile time in contrast to normal variables that are initialized at runtime. So compile time is different. Runtime will be like when we type, run program.exe. versus when it's compiled to make the exe in the first place. The component of the Rust compiler that evaluates such initialization expressions is called the constant evaluator, or constant evaluator. Its functionality is still limited, but there's ongoing work to expand it. For example, in the allow panicking in constants RFC. Now, this was written back in 2018, so a lot of things may have changed in the last 45 years. So that may actually be a bit more built out since. No telling. I haven't had a chance. I haven't looked. The issue with the color code new would be solvable by using constant functions, but the fundamental problem here is that Rust's constant evaluator is not able to convert raw pointers to references at compile time. Maybe it will work someday, but until then, we'll have to find another solution. Lazy statics. Okay, so I saw that at the top of the page where it mentioned lazy statics. Where was that at? Right. Yeah, here it is. Lazy statics. So we have a global writer instance that can be used for printing to the VGA buffer, used by print bang and println bang macros. So we need to add lazy static to crate to our project, which we've done. Yeah, lazy static dependency. There you go. Spin no standard. Standard in or standard out. We don't link the standard library. With the lazy static, we can define our static writer without problems. So we add in VGA buffers. We have lazy statics. There's lazy static. And then the lazy static bang. So this is the global buffer. Public stat reference writer. Writer equals writer. Column yeah, so they at some point he will change this in the doc. So we'll have to come back to that later. Column position 0. Color code new. Yellow foreground, black background. And again, unsafe, mutable, dereferencing, immutable, and then referencing it again. However, this writer is useless since it's immutable. Okay. This means we can't write anything to it since all the write methods take mute self. Okay. One possible solution would be to use a mutable static, which mutable static variable accessing or modifying a mutable static variable. Okay. Global variables does support but can be problematic with Rust's ownership rules. If two threads accessing the same mutable global variable can cause a data race. Okay. And Rust global variables are called static variables. All right. Using static mute is highly discouraged. There are even proposals to remove it, but what are the alternatives? We could try to use an immutable static with a cell type like ref cell or even unsafe cell that provides interior mutability, but these types aren't in sync with good reason, so we can't use them in statics. So there must be some kind of conflict if you try to use those. So let's see, a ref cell. Interior mutability is a design pattern in Rust that allows you to mutate data even when there are immutable references to that data. What? Normally this action is disallowed. To mutate data, we use an unsafe code inside a data structure to bend Rust's usual rules that govern mutation and borrowing. You don't want to do that. I can understand now why you don't want to do that. It makes complete sense. Why would you want to include something in Rust that breaks the security rules against being memory safe? Wow. Okay. Yeah, that makes sense. Okay, so we can't even say spin locks. Spin locks. To get synchronized interior mutability, users of the standard library can use a mutex. It provides mutual exclusion. Okay. Mutex, mutual exclusion, MUT and EX. All right. By blocking threads even when the resource is already locked. Our basic kernel does not have any blocking support or even a concept of threads, so we can't use that either. However, there is a really basic kind of mutex in computer science that requires no operating system features, the spin lock. Okay. Instead of blocking, the threads simply try to lock it again and again in a tight loop, thus burning CPU time until the mutex is free again. Doesn't sound like a good idea. Well, we'll see. All right, so in Cargo Toml, we need spin 052, which has been added for our safety. All right. And then we can use the spinning mutex to add safe interior immutability to our static writer. So this is where we're getting the mutex writer new. Yeah, so that's where we add that part where we're adding the immutability, interior mutability by adding the spinning mutex. We can now delete the print something function and print directly from our start function. So that's why when I did a search for print underscore something, I couldn't find it anymore. So there's no more print something there. See, this is what kills me. If he'd have just said, here's the code, and then we'll walk through those lines together, that would be far better. I don't understand the teaching mechanism here where it's like, I'm going to teach you something and it compiles, and me, like an idiot, I'm like, oh my God, what did I do? And then I go back to the book. Oh, that should happen. And I'm like, I don't want to know that's bad. I shouldn't do that. For me, that causes me consternation because I'm already speaking to ones of people about, learning Rust, and hopefully they're following along with me. And then, shit don't work. And then I've got to figure out, oh, it's not my problem. That's as intended. So it is what it is. I'd rather learn the correct way first. Yeah. I don't even think they teach that in university, right? At least in the last 5 years when I was talking to people about how they teach coding in schools, they pretty much teach you the wrong way first. And then like last year's like, oh yeah, you shouldn't do buffer overflows. Buffer overflows are bad. Now, I don't know if it's gotten any better, but it would seem to me you'd want to learn, hey, here's how to not do a buffer overflow, or here's how to not allow code injection into your environment. Here's how to not, initialize variables that shouldn't exist, or, those kinds of things. So we need to import the FMT write trait in order to be able to use its functions. So here's that. We're going to use core FMT write, which is, where's the main RS. Okay, so it says there's 2 issues with my main RS right now. I don't know what those are. I think we may have hit upon a spot where we need to actually add some things. I think I may have gotten down to this far on there. You'd be better off learning from a boot camp since they don't have the time to do all that. Do they actually teach you the proper way to code at a boot camp, Beta Wolf? Or is it just like, here's the things that are going to get you hired at a company like Google? Comp sci degree and boot camp will typically get you much further in SWE than a comp sci degree. Okay. I have neither comp sci or a boot camp for that. So, all right. Now I don't know why I don't have the main RS code. Let me go see what the main RS code says. Oh, there we go. Post 3. Well, that didn't work. There we go. All right, so we go to source, and then we go to main RS. Okay, so I have everything he has in his thing. At some point, we're going to go back in and remove all that stuff, it looks like. So, as Sam Jackson said in Jurassic Park, hold on to your butts. So, at some point, we'll get rid of this use core format write and get rid of all of this stuff because we won't need it once we're done. Well, technically, we won't have hello again and some numbers and all that because those were all examples to show you that they were writing those in. So, safety. All right, so safety. Note we only have a single unsafe block in our code, which is needed to create a buffer reference pointing to B8000. After all operations are safe. Rust uses bounds checking for array accesses by accesses. It didn't come off right. It uses bounds checking for accessing arrays by default. So strike that, flip it. So we can't accidentally write outside the buffer, which is great. Thus, we encoded the required conditions in the type stream and are able to provide a safe interface to the outside. A println macro. Now that we have a global writer, we can add a println macro that can be used from anywhere in the code base. Rust's macro syntax is a bit strange, so we won't try to write a macro from scratch. Instead, we will look at the source of the println bang macro in the standard library. I wonder what the closed captioning is going to look like for when I say things like this. Println bang macro. Probably going to say print lynn bang instead of an exclamation point. So meta because I can just see the lines on the screen. Anyway, all right, so macro export and then macro underscore rules, and that's going to be in, is that in VGA buffers? There it is, macro export, macro rules, bang, print, and then we have these lines. We're going to add, so we added a new line here according to where we're at currently in the script. And then arg tt print squiggly line, new line, format args. Macros are defined through one or more rules similar to match arms. The println macro has two rules. First rule is for invocations without arguments. Example, println bang, and then parentheses, which is expanded to print / new line. And thus just prints a new line. So the bang is the macro, right? So we just told it, this is what we want print bang to do. We want it to print the new line. Second rules for invocations with parameters such as println hello and println number 4. It is also expanded to an invocation of the print bang macro, passing all arguments and an additional new line at the end. Okay, so the print macro is defined as this. So this is our macro for printing things. Macro rules for print. So this is how we wanted to format everything and use underscore print with various formatting args and then the argument. This calls the print function in the IO module. The crate variable ensures the macro also works from outside the standard crate by expanding to std when it's used in other crates. Does she show the code the macro is actually running? I don't know yet. We'll see. So we put those in. Let me see if I can scroll down and take a look here. So at some point he's going to have us run the hello world again. I don't think he does, Beta Wolf. I don't think he says, does he show the code mark? Yeah. I don't think he shows the code that's how it works when it's actually running. The idea is when we recompile this, and as you can see every time, he wants to make sure when you run, your cargo build, cargo run, QEMU pops up and says hello world properly. So there's going to be, we will have some panic messages. As expected, we now see hello world on the screen. Okay, so where did I get to? I think I got to this point, right? So yeah, okay, it's highlighted. Macro expands a call to IO, to print to the VGA buffer. We just copy the println bang and print bang macros, but modify them to use our own print function. So instead of using the ones inherent in Rust, we have to build our own because we're going to handle things differently until we get a new system in. Hey, Digital Warhead, what's up? We're learning some Rust today. So this is a long chapter because I'm about halfway through. As you can see here on the screen, I'm about halfway down on the screen. Yeah, so, okay. One thing we changed from the original println is that we prefixed the invocations of the print macro with the $crate2. So $crate print using the print macro, because the bang means a macro. And then this ensures we don't need to import the print macro 2 if we want to use println. Okay. Didn't know why $crate was there, but that's cool. Like standard library, we add the macro export attribute to both macros to make them available everywhere in our crate. So macro export. Okay, so it's exporting those and making those available. So we've created our own macros for print and println, and that's how we want it to work. We print whatever it is, and then we print a new line. And we wanted to make sure we exported everything out so we can use them both interchangeably. Like the standard library, we add the macro export to both to make them available. We note that this places the macros in the root namespace of the crate, so improving them via use crate VGA buffer println does not work. We have to use crate println. Okay. I mean, not exactly sure why that's the case, but okay. Print function locks our static writer and calls writeFMT method on it. This method is from the write trait, which we need to import. The additional unwrap at the end panics if printing isn't successful, but since we always return OK and write str, that should not happen. Since the macros need to be able to call _print from the outside of the module, the function needs to be public. However, since we consider this private implementation detail, we add the doc hidden attribute to hide it from generated documentation. Really? Where? Where's that? Maybe it's in the next line here. No? Doc hidden attribute. Oh, I see. I see. That's interesting. So you can hide things that you don't want documented when Rust goes in, and you can make documentation on these things. So you can actually hide your little peccadillos, and that's dangerous too. It's like you want to document how everything works, because if we were to do something and it didn't work and we're like, hey, let's consult the documentation, and we've got a lot of doc hiddens in your code, the people are going to look at your documentation that has been generated and are not going to be able to troubleshoot well without going through every line of code and going, oh, he did doc hidden. So maybe that's something you could look at if you're running into issues where you don't necessarily get what you need out of the documentation. You would go in, first thing to look for would be doc hiddens, or places where the code is going to be obfuscated by the system, and go, okay, what is the doc hidden stuff telling me now that I didn't know when I was reading the documentation that it was generating from the rest of the items? Maybe the answer to why something isn't working is hidden inside of your areas that you don't want people to know about. Doc hidden feels like the rug that you're going to sweep all the bad shit underneath. So, Riverside.fm does not block bad words. But when I tried using Office 365 for transcription, because it does give you the ability to upload your transcripts, it put asterisks in for like bad words. So I would be like, well, what's this bad? Oh, I said that. I said the F word there. Okay, that's what that is. So it was kind of cool to see one of them would censor me and the other one wouldn't. So I ended up going through and censoring the bad words in Riverside FM's output, but it's neither here nor there. All right, so we've got our doc hidden here. One thing we've changed is we prefixed the invocations in the crate 2. We don't need to import, yes. writer and call FMT. Oh, I already looked through all those. Hello using println. Now we can use println in our start function. So the QEMU function that I've, when I run the application, I'm already getting whatever we're doing at the bottom of the page. So the hello world is what we're going to get when we run all this again, because I haven't made any changes at the end of chapter 3. So now that we have println macro, we can use our panic function to print the panic message and location of the panic. So we've wrote a bunch of stuff, and then it's like, well, if we just go ahead and make the macro, we can get rid of this 5 bits of code. I do appreciate the need for him to improve his code as he's going along. So he had a method to his madness. He wanted to teach you that, okay, you can write it like this, but then if you add this little bit, then you don't need this other bit, and you can simplify your code or make it hopefully more readable. Hopefully more readable. Where is it? Oh, this is in main RS. All right, so this is why he changed his kernel panic here. So panic info at panic info, and then here's a bang. I'm assuming the bang is the macro that you're going to call. Refactoring code. Yeah. I actually got told, speaking of refactoring or redesigning things, Beta Wolf, you know Digital as well, or anybody else who's on chat, how long should it take a container to come up? Because I was talking to a friend of mine, and he was telling me about a process that he's building. And I said, oh, well, it must be super speedy. And he's like, no, it's not as fast as I thought it would be. Our container, for each time we start our container, takes 6 minutes to come up. 15 minutes at max? Fuck. Beta Wolf, do tell. Why 15 minutes? The problem is he's got people using them, so the containers will come in as the people are using them. So somebody's going to sit there for 6 minutes and wait for that thing to come up. We're trying to figure out faster ways of doing that. If it's like you take the bottleneck out and put it into its own container, maybe let it run, kind of, because he's got 2 containers. One is controlling the other container. And I was like, you need to figure out what in this container is causing the bottleneck, and like maybe containerize it off so that it's only called at a certain time, or maybe you can leave it running to lessen your need. On my Proxmox server, containers start within seconds. Virtual machines take a little longer. Some containers are pretty built out, and the node container system can cause massive bottlenecks. Oh, this is on a public server. Never mind. Oh. Yeah, he said it takes 6 minutes, and I was like, oh my God. And he's like, yeah, what we're planning on doing is keeping some containers warm so that when a person comes in, they'll do that. And I asked him, I was like, confidentially, what are you using that for? And he's like, well, we've got some old code that's not being, supported anymore by open source, and we have a long lead time to replace that code, and we want to put it into a container to save it. And I was like, well, and feel free to let me know if I'm wrong here. We're gonna digress a little bit, but I was like, if you leave that container always on, and somebody figures out that old code is running in that system, that's a persistence point. So you would want to break that down as soon as you can. So if the bad guy gets onto that container and starts trying to execute code, that container will go away. He'll have to get persistence fairly quickly if he does. Not unless you use Podman. Yeah, we don't use Podman. Well, at least my friend doesn't use Podman. I actually need to put Podman on this computer. I bet it'll work. Yeah, I've got 80 gigs worth of RAM. I could probably run a couple containers. Actually, what I'll do is I'll probably get my Think Center over there and put some Podman on it. Yeah, that makes more sense. But yeah, so it was like, we were trying to tell them that, you do need to shut that down from time to time, or, have some in reserve that aren't being used, and then rotate them out and, destroy this old one, and then, build up new ones as you're going along. That way it doesn't take 6 minutes to do things. And if the bad guy does get persistence on that one, it'll go away in 1 or 2 minutes or quicker, hopefully. And then the bad guy would have to reestablish persistence. So ideally, we're hoping that that's noisy and that will generate logs that the detection teams can see. And he was very, very grateful for that. He said it will, take a little bit to implement. So, but you run into that kind of stuff all the time. So I just wondered if there was a better way to architect those so that it doesn't take 6 minutes. Like Digital Warhead said, it's started within seconds, but Beta Wolf said there's a lot of stuff with Node and whatever. So yeah, there's probably a lot of dependencies. One of the things that I suggested to him was SBOMs and figure out what else is not being patched on that system while you're waiting for new technology to come in a year or so. So yeah. Anyway, back to our regularly scheduled program already in progress. Now we have a println macro. We can use it on our panic function. So we've rewritten the panic handler to use the println macro right there. And it's going to println all the info, all the things, SBOMs. Swearing the machine will not speed it up. Oh, digital. Yes. You're absolutely correct. It will not. It will not make anybody feel better by swearing it. Well, it makes me feel better sometimes. I was swearing at this box, Digital Warhead. You know what I was talking about? Swearing at this box. By the way, everything's still stable. Digital. We're using it right now. It's laying on its side. I don't know. Like I told you, they sell those things on Amazon to keep the graphics card from sagging. So I'm like, maybe it is a saggy. Maybe my graphics card is sagging. Anyway, sounds like a personal problem to me. All right, now when we insert some panic message, our start function will now get the following output. All right, so yeah, then that's good. We want to be able to see that if something goes pear-shaped, then we want to be able to see there's some kind of error message when we're poking around and we did something wrong, or our OS doesn't start up or something like that. Because at some point we're going to be loading drivers, right? And we want to be able to know when the kernel's decided, oh, I don't want to do that anymore. I'm good. Let's just go ahead and panic. So we know, oh, we're done. Whoa, there must have been a ton of comments on this. Oh, yeah. Oh, my goodness. Okay, well, we can go read through some of those. I didn't know we were that close to being done. Okay. So we know not only that a panic has occurred, but also the panic message and where the code happened. I wouldn't necessarily advertise that to Joe Public, but if you're wanting to debug something when you're in testing, you would add those kinds of symbols, and then you would want to remove them so you're not telling people, hey, go to there's some hot garbage in main.rs at line 25 character or line 28 character 5 or something like that. I think that's the name. I think that's it. All right, so in this post, we learned about the structure of the VGA text buffer and how it can be written through the memory mapping address at B8000. We created a Rust module that encapsulates the unsafety of writing to this memory mapped buffer and presents a safe and convenient interface to the outside. Thanks to Cargo, we saw how easy it is to add dependencies on third-party libraries. The two dependencies we added, lazy static and spin, are very useful in OS development, and we'll use them in more places in future posts. What's next? Next post explains how to set up Rust's built-in unit test framework. Then we'll create some basic unit tests for the VGA buffer module from this post. Kriznap. So that next chapter is where I don't have anything in here yet, so we will give it a good shot on how to fix it. Again, my problem was, especially when you go into testing, if you go into his chapter 4, you're only going to see what the code looks like at the end of the chapter. So in the first 5, if he changes some major shit at the beginning of the chapter or at the end of the chapter, I won't understand why or how or when he added that. So, well, we'll continue trying to get through this. So chapter 4 stuff is right. So no more boot image. Interesting. So yeah, we're going to add some other stuff here. Bang feature, custom test framework, OS test runner, re-export test harness main, test main. Interesting. Okay, so and we're going to add serial.rs, probably a serial port maybe, and librs. So there's different. Oh, looks like yeah, we taken public mod serial, public trait. Oh, we're going to learn about traits. Okay, so yeah. Oh, and then there's some QEM exit code stuff. So it's good that we've got our QEMU set up for this, and that way we'll be able to have it. We still have some of our original stuff, but it looks like we're popping that off into something else instead of VGA buffers. So we still have our VGA buffers. I don't know if there's anything new or changed in here, but all right. So close that. Close that. And so best way to support him is on GitHub, Patreon, DonorBox. And so let's see what some people said here. We will, there we go. For whatever reason, when I call my implementation, I don't have to call unwrap, yet I need to call it from the macro. Either I did something wrong or some difference I have yet to find with the tutorial in my code. Yeah. I have the same problem. Make sure impl writer doesn't have a write stir method. Yeah, there's a at least I'm not alone. I mean, there's a good number of comments here for this. Looks like some other people picked it up in 2022. So that's kind of another 131 items. Jesus, good grief. Okay. Oh, so he's still pretty good about answering his questions. He must have gotten a lot of traction out of this one, so that's really nice. He's still answering questions even 2022. The Uwu colors crate is used to create the ANSI escape codes. Okay, styling the output is something you need to do yourself, right? That exceeds his bits here. Okay. Oh my goodness. Okay. Well, so we finished chapter 3. Next Friday. Let's double check to see what next Friday is. Next Friday, Halloween. No, it's not Halloween. It's the 28th, I think. Why can I not see this? Please stop doing that. I just want to see the calendar, you rat bastards. Can a brother see a calendar? I mean, Jesus, man. Can't. That's why we can't have nice things. This is Windows 11 Home, which I found has a couple of other, things about it that I don't like. Okay. 7:09 a.m. Time sync failed. What? There it goes. Lunar calendar. I was hoping to see the calendar. Anyway, yeah, we'll be back on next Friday, hopefully. Yeah, I hope everyone had fun watching the VOD here. Once I get everything straightened out and I'm a bit more in my new element with my mental health, I'm going to start taking stock of what we're doing with the podcast and with some of the ways of which people can support. I know if you're watching this on YouTube, you're like, I don't like Twitch. I'm not going to support him on there. We still have a Patreon. You can still go and support us on that. Patreon has started changing some things around so you can give different prizes. So like if I'm going to be looking at setting up like a VOD YouTube channel. So if you are a supporter on Patreon, I will get you a VOD playlist link where you can go and pull those ahead of people who are not necessarily supporting the show. Because like I said, for years, I felt bad at people who are supporting the show on Patreon, but they don't really get anything out of it other than listening to my dulcet tones. I was actually looking at, got new logos so we can get new merch, new limited edition t-shirts or stickers. God knows people still love them, some stickers. Actually somebody made my day today. One of the people who I saw at Black Hat, I gave him 3 or 4 stickers, and he's in Mexico at a security seminar, security event that he's speaking at, and he had some BrakeSec stickers out on his on the table that he was sharing with some folks. I was like, oh, you made my day, so it was really nice. If you have a .edu email, you can access many Windows OSs that include license keys, Windows 11 Ed, which is the same as Pro. Oh. Well, I can, yeah, if I did get a Windows 11 license, Digital Warhead, I probably would wipe my machine and start over. The fact that I'm using the base version that came with it from CyberPower PC really skeeves me out, because I was one of those people that every time I bought a Dell, the first thing I would do is I'd wipe the machine and put a new OS on it. I've done that with my Lenovo laptops. Everything that I've done, it's like I don't want the one that came from the factory, if you will. I don't know why that is. Maybe it's just because I'm a paranoid mofo. But yeah, it's like the other thing is, yeah, I can get licenses for fairly cheap because my wife tends to work for a small software firm based out of Redmond. Do a fresh install when the PC is still new so you don't lose anything. Exactly. And the problem, Digital Warhead, is I didn't have that luxury. I needed to be able to test things. I needed to be able to get set up and running from my old computer to my new computer. So I didn't have a chance to do that. I am diligently making sure that I'm not putting stuff in tons of different places. Yes, I will have to reinstall a bunch of stuff and probably my Rust environment, all that when I go to do that. But yeah, it's unavoidable at this point. But it is what it is. So, cool. Well, I'm gonna go because it's Friday and I'd like to get my weekend started. I already started my weekend with you fine people, but I'd like to be able to go and sit, and maybe I'm gonna sleep pretty well tonight. I had a heavy chest day. It's good to see those gains in the mirror. It's one of the few things that I've enjoyed since moving back to San Diego, is finding a good trainer. Hans kicks my ass. His name is Hans, not of Hans and Franz. It just happens to be his name, but he's a veteran and it's awesome. Slap a second SSD in there and save Rust. Anything else before a fresh install? Yeah. I've got a 2 terabyte USB-C drive on there right now, and I've got, well, this one's 4 terabyte NVMe drive. So yeah, so 4 terabytes with cooling tape and stuff in there. Digital, when my doctor, not to harp back too much on that, but she was like, "Are you an impulse buyer?" And I was like, "What do you mean?" She's like, "You go to Amazon.com and always buy something?" Yeah. So yeah, that was one of those things. It was like, "Oh, I need a hard drive. Well, let's just go ahead and buy a 4 terabyte one, and with an enclosure." So hopefully some of the medication that I get will help me be less impulsive in buying shit. So, because I bought a brand new computer. Yeah. Shopping is a thing, and portion control, impulse control is something that I also struggle with. So impulse control, portion control, it's all impulse driven and it's all lack of focus. So it's going to work. I wished I was, I've probably spent over the course of 10 years with different configurations. I mean, just in the last 2 years with the podcast, I have bought at least 2 ring lights, 3. Well, I bought my SLR, which was about $800, which I don't use anymore. I bought the Facecam Elgato Pro right here, which is another $300. I've spent a fair bit of cash on this stuff. Stream Deck, I'm an Elgato whore, basically. It ain't cheap to look sexy. Well, I could put a bag over my head, and I'm still not looking like some of those other folks that are on those professional channels. I'd love to do that. I did see a really cool job that somebody posted online. If you'll indulge me, another. No, that's not Well, that's one of them. Netflix is looking for a third-party security engineer, remote, United States. I mean, they've been remote forever, so don't worry about the RTO stuff. I would worry about like they're going to pay you less if you live in the Midwest versus like on the coasts. But they do have that option. Where is it? Oh, here you go. So this one was kind of cool. Content security manager, and I was reading through it, and it's a full-time remote position, but Pacific Standard Time business hours, so they're probably in like I would say they're headquartered maybe in SFO or someplace like that. But they, the role of the security content manager is to manage content security programs domestically and internationally. I don't know if that's for companies. It's like an LXP position, like a learning platform kind of thing. Lead risk management efforts across various teams and external partners, contribute to strategic planning for global security operations programs, and be a driving force in raising content security standards within the industry. That's nuts. I mean, that is super strategic. I mean, it makes me sad that I would really like to apply for that job. But one of the other things that my new doctor had told me was people with, our kinds of issues, we tend to jump jobs quickly. And I have been at my current job less than 3 years. And I know that there are people struggling out there trying to find jobs. And if I'm currently gainfully employed, I don't feel like I should just randomly jump jobs. But that is a sexy ass job, and I've reached out to I actually contacted the talent acquisition specialist, and I said, "Holy crap! Good luck on the hiring. Really cool job, because you need 5 years of security management experience. Yeah, got a CISP. Yeah, I have a degree in IT. It's not computer science or anything." The only thing that would really kill me is this: study of nonlinear editing, Avid, Adobe products, or production IT concepts. I'm still learning how to use DaVinci Resolve, which is like the gold standard from what I understand anyway. Hollywood uses this stuff. I mean, they use Avid as well, but if I know DaVinci Resolve, it's all kind of the same workflows. And then familiarity with operating system, I can learn enough on that. And if I'm the manager, there's probably a team of people, but that's not fat. That's some fat loot right there. I wouldn't turn that away. There's 1 to 10 employees though, so it's super startup-y. So, but that was a really cool job. So yeah, I did hit up Heather on that. You rarely see a job where you're like, I really want to go and do that. Sure, Digital. I added them both to. If you're on the Discord, I put them in the jobs thing as well. They're on the job board for both the Discord and the Slack. So, what was one of the other ones? Looks like. Let me see. What's this one? Her. GoFundMe is looking for a senior staff security engineer as well. So you can, they're looking for those. That job is also in our Slack channel. If anybody wants to join, let me put an invite link to the Slack for those of you who want to come and join us. Remember, we're moderated. We have Lady P is one of our moderators in there. I'm a moderator. We don't suffer fools, and we'll ban your ass if you don't. You don't follow them. We expect professional behavior at all times. The Discord is similar. Myself, Mr. Scott Pack, Lady P are also in there. Making sure and keeping the peace. And yeah, a lot of good stuff. I've been cleaning out my bookmarks as well. I don't know why I'm on a tangent now. I wanted to go and leave and stuff, but I've been cleaning out some of my bookmarks, and I have a lot of bookmarks. Like, a lot of bookmarks. I mean, I can't even tell you. Yeah, you can't see them because when you click on bookmarks, I have so many 20 years worth of bookmarks for things that, like, numerous starter guide to Linux forensics, security sift. I mean, some stuff is old, but I've been adding a lot of these links to our education channel on our Discord and on our Slack. And it's stuff that I would say is fairly evergreen. Like here's some SCADA and ICS PCAP files. You know, here's capture. Some of these are old, but they're still PCAPs, so you can still look at them and oh, Krisnap. You know, some of them, you know, are, and then like some of these are completely useless, and then I'd have to, I toss them out anyway. But yeah, so there's a number of different things here. You know, starter guide to Linux forensics. You know, it's from 2017. A lot of these are from 2017, 2018, when we were still like thinking about podcast topics. But, you know, some of the stuff's still fairly valid today and evergreen. So you can read through some of these items, and, you know, some of these blog posts are still around. Some of them are on like Internet Archive, that kind of thing. I had so many, let me see, not all commands. Was that all commands from sorted last week? Crypto challenges. Crypto puzzle challenges. Nope, that's a dead one. Okay, so yeah, I've added a bunch of stuff in here. Upgrading shells to fully interactive TTYs. So if you're needing a shell and you've got a half-assed one from you know, Netcat or something, you know, you can, you know, generate a reverse shell command. There's MSF Venom payloads that you can use. There's also a Python method that you can use to create a TTY out of a restricted shell. So that's pretty sweet. You know, a lot of this stuff's still fairly evergreen, using SOCAT for those items. I find all this stuff and I made bookmarks and I just never come back to them. Weird. It's like I lost focus and I planned on coming back and looking at those things and they never happen. Nowadays, people just have 500 browser tabs open and they totally forget what they're doing there. But yeah, so I mean, there's a ton of stuff that I still have, and I'm copying that stuff in because, like I said, it's evergreen. The stuff's still going to work, you know, in many environments. You know, stuff that's like, you know, like SIFT, or if they were talking about like, you know, 5-year-old Slack, or not Slack, but 5-year-old. You know, detection methods using Splunk or something. I was like, yeah, it's okay. But yeah, so there's a ton of stuff here. So Under the Wire, oh yeah, Under the Wire, that's PowerShell training. So it's PowerShell war games for folks if you want to, you know, practice up on your PowerShell. That's a pretty cool war game system, kind of similar to Over the Wire in that respect. But yeah, so all right. Well, I'm going to go before somebody raids us and I feel bad about kicking them all out. Have a great weekend, y'all. Take care. Be safe. Think about yourself. Think about, you know, your love yourself enough to, you know, be real with yourself. If you think you've got an issue, seek help, talk to people. If you're feeling bad or down or lonely, I want you to continue circling this, you know, interstellar medium with me. So please reach out if you need help or anything. Okay. All right, y'all. Talk to you later. Bye.